Good morning, good evening, good afternoon, wherever you are. Welcome to the presentation of this version 1.1 of the Connected Autonomous Vehicle Technologies Standard. My name is Leonardo Chiarione, and I am the president of MPAI and quite involved in this project because I believe it is very important. Before presenting the standard, let me say two words about standards. So what are the benefits? So the 10 benefits of a standard: interoperability, the system can interoperate, consistency, because you have a uniform framework. So many things that can have a different meaning, values, and so on are consistently defined. Efficiency: if you have a standard, you can reduce development time, the cost is lower, you can accelerate the deployment. Quality and reliability. Well, because you have a standard that embeds the know-how of many participants, then the result is your product is higher quality and more reliable. Scalability. You have already referenced inside the standard to other standards. Innovation. I mean, this is not the manufacturing or development side, it's more the creation of new technologies. There's wide room for creating more technologies, but you can concentrate on higher level improvement and not the minute things that are in any case necessary but can be taken for granted. Market expansion. Your product can have is usable across systems and regions. Less risk because of compatibility, maintainability, and the long-term support, and the compliance. Compliance is, in particular in this case, very important, and it is easier to establish compliance and verify compliance. Finally, knowledge sharing. It's because collecting expertise is shared among participants. But I've said something about innovation. There is one argument that is made that if you have a standard, then you are basically an implementer and you have no room for innovation. Well, nothing is more wrong than that, but there's a condition. We're not talking here of a general standard, but interface standard. And interface standards specify the component of a system, the function of the system, and the interfaces of the system, and of course, how the system interconnect. Therefore, implementers have the freedom to use any relevant technology and IP, of course, to implement components, to split components, to merge components. And the condition is that the component that you obtain by splitting or by merging should expose the right interfaces and, of course, have the specified functionality. Interface standards offer opportunities because research and technology development can offer better components in a plug-and-play fashion. A component can be based on artificial intelligence, but the difference is that you have more control over what is happening inside the system. It's possible to develop a market where open market of components are offered. And autonomous vehicles are important because they make transportation more efficient, secure, and environment friendly, and they expand and enhance the value of autonomous vehicles if the vehicle can also communicate, and communication is an important part of this standard, as you will see in a minute. The connected autonomous vehicle is designed to enable automotive to exploit the value of interface standard for connected autonomous vehicles. That's the reason of my dealing with this, the value of standard. So, if you don't know about MPAI, or you don't know enough about MPAI, so this is the opportunity for, we are a non-profit organization incorporated under the law of Switzerland with a mission to promote the efficient use of data. And how do we do that? We develop standard. Standard for what? For coding technologies. Coding is not compression. I mean, it's also compression, but coding is representation of information. And AI is about the data and how data are represented. But also system technology that facilitate the integration of standard components into more general communication, information and communication technology system. But also bridging the gap between technical specification and their practical use. What does it mean? It's that very often the standard exists, but you cannot use it. You cannot use it because the rights holders have not made up their minds. Well, MPAI has developed intellectual property right guidelines, and the framework license is something on which this standard also relies. So how do we develop a standard? So we have somebody saying, I think that this standard should be interesting, and that is not a good reason for start working, but we can start collecting interest in the standard. We develop use cases, we develop functional requirements, and finally, we developed so-called commercial requirement. Of course, we are a standards organization. We are not dealing in commercial requirement. But the framework license is something that can be considered akin to commercial requirement. And that is something that is developed. It is an important part of the context of the standard. We are ready to issue a call for technologies, which we have done. We receive submissions, and we started developing the standard. After some time, and in this case, it took quite some time because the standard is very complex, we have something that is ready for publication, but not yet. So we wanted to, before that, to publish publicly with a request for community comments. After a certain time, we are ready to issue the technical specification, and later on, reference software conformance testing and performance assessment. So what have we done over these years? Quite a few things. You see here the list of a standard, which is we cover a wide range of application domains. So we have, say, a human and machine communication. You have a metaverse. We have neural network watermarking. We have portable avatars. We have the connected autonomous vehicle, of course. We have a finance, compression understanding of industrial data. That is what we are doing in this space. And quite a few of our standards have already been adopted by IEEE without modification. And we have 5 more in the pipeline. Okay, so that was about how much we have done. But it's more important to talk about the value of what we have done. I started from what I consider a foundational standard for MPAI, which is the AI framework. What is the AI framework? It's the specification of an environment where you can execute AI processes. So it's quite an elaborate standard. It defines a wide set of APIs, that you can use to implement this environment. And then once you have that, you can plug in these AI modules, which are the basic elements that process the information. I want to spend 1 minute to talk about the processing trust framework, because it is important that the environment be trusted, which means that if an AI module is connected to another AI module, it wants to make sure that it can trust the AI model. And so we have developed this processing trust framework standard that gives you methods to assess the cryptographic identity, verifiable credential, attestation evidence, policy bindings, trust protocols, and once the trust is established, AIMs, the AI modules, can exchange what we call data exchange metadata, whereby the receiving AI module knows more about the data it is receiving from another AI module, granted that the trust has already been established. So this is a shift from implicit trust to explicitly verifiable, policy-driven trust. So these are two highly relevant standards that I wanted to present briefly. Now let's go to the connected autonomous vehicle. So we have in MPAI developed a modern way to publish a standard. So what you see here is a web page, and if you click on any of these links, you will go, for instance, let's go. What is the scope? The scope is defined here, and if you go to the website, and indeed the website is accessible, it's publicly available. You can read everything that is in the standard. So the architecture, we assume that a connected autonomous vehicle is land-based and is composed of three things. The first one is very important because that is the core of the standard. It's called connected autonomous operation. And it does the standard functions of an autonomous vehicle, with an addition that it has also communication capability. So it receives a request from a human to take him or her to a specified place. It captures the data from the environment. It exchanges this data with peer connected autonomous operation element from onboard other connected autonomous vehicles. It issues control instructions to brakes, motors, steering, and complies with applicable laws properly represented in digital form. In the standard, you have the representation of the Vienna Convention, but of course there are other other convention in other regions, but for them it is necessary to develop this digital representation. So the second is brakes, motor, and steering, and the third is the rest of the vehicle. So the core is the connected autonomous vehicle, but we are interested because there is a dialogue, obviously, between the connected autonomous operation and brakes, motor, and steering. Okay, so the connected autonomous vehicle is obviously the brain of the vehicle. It is implemented as a big AI module. It is executed in an AI framework instance, and it is implemented according to the AI framework standard in the sense that it can access the MPAI AIF APIs. The operation is such that the module is operated to fulfill the goal of a connected autonomous vehicle, and this is done by exchanging data enriched with data exchange metadata, as I have said, and as specified by this standard. Let's look inside. Okay, so this is a very general representation of a connected autonomous vehicle. So this part, surrounded by the black lines, this is the connected autonomous operation. And the brakes, motors, and steering wheels are something that is external, but of course there is a dialogue, there's a comment and response dialogue with each of these elements here. And here we have four smaller, but still very big AI modules. One is the interaction between the human, or it can be the service, and the connected autonomous vehicle. Then we have the environment sensing subsystem. We have the autonomous motion subsystem and the motion actuation subsystem. I mean, the meaning of the terms is pretty obvious, but I will go into details in the next slides. So the connected autonomous operation. Well, this is a very big thing in the sense that it receives a lot of data and produces a lot of data. It would take too long for me to deal with all of them, but we will say more in the next slide. And of course, you see that we have brakes, motor, steering, providing responses, but also providing the actuation. So this is the representation of the connected autonomous operation. We said that it is composed of four AI modules, and here we have represented all the data that are involved in the connected autonomous operation. Let's look more at the next AI modules. The human CAV interaction. So this is really something that here you have a user, and the user is captured by the environment sensing subsystem. And we have a front end that is the audiovisual scene description. So it's a very powerful AI module with a lot of intelligence to understand the audiovisual scene outside. Not just that, because as you will see, we try to know more. Of course, we have obvious elements like the automatic speech recognition. We have identification of objects. We have a face recognition, of course, and we have a speaker recognition, of course. And what is interesting here, well, this is the natural language processing, which is an obvious component. But what is rather new is the fact that we have a personal status extraction, in the sense that the connected autonomous vehicle should be able to have an understanding of the state of mind, the emotional state of the user. Based on that, on all these elements that are connected here, the entity dialogue processing, of course, receives text. It receives also an understanding of the meaning. It knows about objects, and it knows about the personal state, which is what I have exactly said, the internal state of the human. Then we have here the response and scene rendering. What is this? Well, we wanted to be able to give an opportunity to the connected autonomous vehicle to be seen and to be perceived as an entity that looks like a human if one wants, but it could be anything else if one wants it differently. Not only, we also have the possibility to view on this display here a representation of the external environment as captured by the connected autonomous vehicle. We also have something interesting here. We have the possibility to establish a dialogue with remote components in other connected autonomous vehicles. And this one is instead the dialogue between the human cab interaction and the autonomous motion subsystem, which is something that we will see in a minute. So here I've given an example of the audiovisual scene description. All this is well specified in the standard, so I don't need to spend time on this. So what is interesting is this response and the scene rendering, because here essentially the CAV receives text, which is what the entity dialogue processing has decided should be uttered, and with that, this is used to synthesize a speech, but also adding the personal status of speech in the sense that the connected autonomous vehicle, actually the human cab interaction, has the possibility to simulate a state of mind that is suitable for the state of mind of the user. So then here we have the synthesis of the avatar, we have the face, we can put a personal status in the face, but also in the gesture. And the result is this scene and avatar rendering, which simply generates visual, speech, and audio that are necessary for the dialogue. So here we have some data types. I think that time is moving faster, and I will. So it would be interesting to have a look at what is the personal status. The personal status is a complicated data type in the sense that it has emotion, but we have considered two other aspects. One is the social attitude. So what is the social attitude that you take when you're dealing with somebody? And we have the cognitive state, which is another element that is well specified by another MPAI standard. The environment sense and subsystem. Okay, so here we start, we mean business, because we have sensors. Of course, we don't prescribe that all the sensors be used. But of course, the more sensors you have, the better performance you can expect to obtain. Here we are considering the use of audio and visual, of course, but we have radar, we have LiDAR, we have ultrasound, and we have other data that are received from other components of the connected autonomous vehicle. So then we have objects here, audio object, visual object, LiDAR object, and so on. And these are processed by this small, but they are still very complicated AI module that convert this visual object, say, into a visual scene description. So we have a information flowing here that is well specified in the standard, but I don't attempt to describe it now. So what we have as a result, we have, say, the visual scene descriptors that come into this basic environment description. The basic environment description is an integrator of the different scene description into a coherent scene description with a proviso. It may happen during the process that one of these AI modules is alerted by something unexpected. In that case, it will send out this alert signal immediately to the autonomous motion subsystem for immediate processing. So let me see. We have again, the data type, the basic environment descriptor is of course very important, but it's kind of trivial from the specification point of view, because it is an integration of of very sophisticated processing that generates the visual description or the audio description and so on and so on. The third subsystem is the autonomous motion subsystem. So what do we have here? Well, essentially, this is the environment sensing subsystem. This is what we have just said, right? What it happens is that it provides the basic environment descriptors, of course, but because every time is not the first time, but there is already a history, it's very useful to be informed of what this autonomous motion subsystem has developed in terms of a full description that takes into account a lot more information, particularly also information that is coming from other remote CAVs that can provide information through this full environment descriptor, which is again this time an integration of internal information but also external information. So this route selection planning is something that is the result of a request coming from the human. I want to go home. Okay, so then the route selection planning has, of course, access to all the necessary information to provide a set of solutions. Some may be very quick but uncomfortable. Some maybe take more time but more relaxing. And then once we have that, the idea is that a route is provided and a path is selected. A path is selected and trajectory is provided. But if something fails, the trajectory, a new trajectory can be requested, can be obtained, but if that is not possible, no new trajectory is possible, then a new path is requested and a new route is requested. What the core is this traffic obstacle avoidance, which is the last AI module that takes the decision, move in that direction for that much time at that speed and so on and so on. As an example, I have this traffic obstacle avoidance, and of course here the standard doesn't tell you how you do things because that is what is the freedom, is the wide freedom that is given to implementer to adopt the more sophisticated solution that they may have available. So here a trajectory is received, then a processing is made. There is this alert information that is something that may be critical. So at the last minute, a child is coming to the street, and therefore you have to take a decision. If nothing happens, a message is sent to the motion activation subsystem, which will make a response. And what happens is we'll see soon, because here we have examples. So, for instance, we have this communication between autonomous motion subsystem and different vehicles. We have the road state and the CAV state. So let me take, for instance, road state. Here you have an example of the specification. So each data type has its own specification, as much as this AI module has its own specification. So it's a data type describing the current physical, environmental, geometric, and traffic-related condition, and so on and so on. So these are the functional requirements, what it should do, quite a few things, as you see. And this is the semantics of the data that correspond to what is given here in this JSON schema. And of course, the JSON schema, in many cases, it had description, but but sometimes not everything is described. In that case, you can come here and you will know the exact semantics of the data that is being handled. So let me move on to the motion actuation subsystem. The motion actuation subsystem is made of not many, but very important AI modules. So this is the autonomous motion subsystem, the one that is deciding do. So then this information is analyzed here and is interpreted here, and commands are sent to brake motor and wheels. And the response is what analyzes the responses from brakes, motor, and sensing. We have an AIM for ice condition analysis. I understand that not all countries have a need to deal with this, but other countries do have that need. These are the sensors, the inertia sensors, and the weather sensor. And indeed, if we go here, no, we don't have it, but let me take this brake command just to show you what the brake command is issued by the motor actuation subsystem to a brake of the physical vehicle and expressing the desired target velocity after a specified time as defined by the standard and additional actuator level command parameters. These are the functional requirements, and these are the quite a few information elements that are not required. It is something that is left to an implementation. An implementation may adopt the full richness of this data set. Others they don't have the need of that, and they take less. Okay, we are close to a conclusion, and that is, let me they say that this is the first interface standard for connected and autonomous vehicles. So you have seen the level of details that you can go, but not necessarily you have to. An implementation can adopt the level of the fine level of specification adopted by the standard, but can decide to merge different AI modules into a bigger AI module. That is a complete freedom that the standard gives to implementers. It includes security protocol for AI-based implementation, which means that we have an AI framework, but the exchange of data between AI module can enjoy the security protocol that are specified by the implementation process instance trust framework. It is composed of a variety of AI modules, and many of these can be AI-based. The standard promotes a market of components and facilitate the development conformance testing beyond the basic conformance testing that is provided by the standard. It can also be used to assess the performance of component implementation. Okay, with that, I have this message: join MPAI, share the fun, build the future. This is a page. It's a very simple way to access the standard. So we have cav.mpai.community, and this you're taken here. And here, if you see, and here you can see that if you, yes, if you remove the about, you are the connected autonomous vehicle, and here you have the version 1.1, and you have the access. This is the page that I have shown you before. So with that, I reiterate my invitation to join MPAI, and our motto is that we share the fun, and we have a lot of fun, I can tell you, but at the same time, we are building the future. So with that, I close my presentation.